now you're on to complex equations. So you've done simple and two-step. So nothing has changed again, okay? We're just doing more steps, okay? So all the rules are the same, but we're just gonna do more steps. So let's take a look at this first one, okay? 5x plus 4 equals 3x plus 8. Now we have x's on both sides of the equal sign. So we need to get x's on one side. Generally, I always say the bigger number stays. So let's move this guy over here. So right now it's a plus 3x, right? So it's plus 3x. So when I move it over, it's going to become a minus 3x. So next time I write this equation, I can write 5x plus 4 minus 3x equals 8. Now you look here and we have this constant here. It's not x, not a variable. So we need to move this over, okay? So that there is a plus 4. So when it goes over the other side, it's going to become a minus 4. So if I were to rewrite this again, I'd write 5x minus 3x equals 8 minus 4. Now I can combine my like terms. 5x minus 3x equals 2x. 8 minus 4 equals 4. Then we're on to here where we have to move this over. And right now it's a multiply. So it's right here for a multiply 2, we need to move to divide by 2. So that's going to equal x equals 4 divided by 2. So x equals 4. Okay? So there it is, all stepped out. We've done nothing different. We just took our time, moved one thing over, other thing over. Right? Always using our opposite operations, our inverse operations. Right? Knowing that when it crosses the equal sign, it does the opposite. Okay? This one we're going to do a little quicker. Okay? We're going to do 2 steps at one time, which is perfectly fine. So if we take a look here, we have minus 2x plus 8 equals 3x minus 7. We say, okay, we got x's on both sides. So I want to keep my 3x is the bigger one. So I'm going to bring this one over here. Okay, let's undo that. I'm going to make this red. I'm going to bring this one over here. But I also know I need to move this 7 over to the other side. So if I look at the red here, I have negative 2x. Oops, wrong one. I have negative 2x. When it comes over, it's going to be positive 2x. Then here, I have minus 7. So when it crosses over, it's going to be plus 7. So if I were to rewrite this, I have 8 here first. My 7's coming over. So it's going to be a plus 7 equals 3x is already over here. But then my negative 2 is coming over, and it's going to be plus 2. Okay, so when I combine these, I'm going to get 15. Oops, that's a 2x. When I combine these, I'm going to get 15 equals 5x. But then I need to move the 5 over now. The 5 right now is a multiply. So when it comes over, it's going to become a divide. So my next writing down, 15 divided by 5 equals x. So x is going to equal 3. Away we go from there. So remember, whenever you get down to this step, you divide by the coefficient being 5, and it becomes a divide. Okay? Let me do this first. Let's erase my numbers. And stop digging. Let's just link these together. Group. Let's bring them all down here. And then once again, I'm working with backwards BEDMAS. I'm doing my subtractions and my additions first. All right, so next one. This one here, I have the y's on one side all together, so I need to move this over, right? So right now I have a positive 12, so it comes over, it's going to become a negative 12. So if I rewrite this, I have negative 12 equals, now I could group these together right now. I could go, what's 8y minus 6y? And it's 2y. Well, I'm at that point again where I just have my term equals another value. So I need to move it over. So at the very last step, I have a multiply. So when it comes over, it's going to become I have a multiply by 2. So it's going to become a divide by 2, which then equals negative 12 divided by 2 equals y. Okay. Oops, I didn't finish that question. Y equals negative 6. Almost went away with it. So now this one's a little different. We have 3 terms on this side, 4 terms on this side. That's a lot for me. So what I'm going to do here, I'm going to draw a line down the middle here real quick. I'm going to collect like terms on each side first. Okay, I can't collect like terms over the equal sign yet. I'm going to collect like terms here. So I'm going to combine 11x and 6x to get, 5x and 6x to get 11x. I'm just going to write that down. And then on this side, I have, oops, I'm going to change that up. I have 3x's and negative 2x's, but I also have these constants. So I'm going to combine those. So now I have 1x and I have 5. Now this is easier to move around. Now all I have to do is move one from each side over to the other side instead of like multiple. So there's less chance of me making error here. So now I'm going to move this x over. The bigger x is over on this side, being the 11x is bigger than 1x. So I'm going to bring this x over. At the same time, I'm going to bring this 5 over because I know I need all my letters on this side, right? So my 11x, and this here is a plus. So when it comes over, it's going to become a minus equals what's already over here. This 5 is already over here. But this 5's come over, it's a minus. So when it comes over, it's going to be a plus. Then combine terms again. 11 minus x is 10x equals 10. Now we're here again, where we have our coefficient with a variable. And we know that we're going to move it over. But the very last step is always, oops, divided by, oh, you little bugger, divided by 10. And realistically, this arrow, I draw this arrow, that 10's going down there. So x equals 1. Okay? The group on the arm rodent. Good. Now this one. I'm going to do this one 2 ways. Okay. So the one thing I could do first is I could rainbow this in and expand it, which will give me 2x minus 6 equals negative 8. Now I need my variable by itself, so I'm going to move this over. So 2x equals negative 8. A negative on this side, negative 6 on this side becomes a positive 6 on this side. So it's going to be plus 6. Let's reduce it. Equals negative 2. I'm here with my coefficient and variable. So I'm going to move that over. And it's going to become a divide. So x equals negative 2 divided by 2. X equals negative 1. Okay. I'm actually going to erase that last line and put it under. So that's one way to do it. But the other way to do it, you could look at me and say, hey, I'm supposed to do BEDMAS backwards. There's no subtraction or addition, but this here, the rainbowing, is multiplication, right? So why don't I move this over, right? And you could say it's a multiply 2 on this side, so when it goes over, it's going to become a divide 2. So if I move that, my brackets will disappear. -8 divided by 2. Okay, x minus 3 equals -4. Then I have a variable and a constant, so I'm going to move this over. X equals 4, -4 plus 3. Because it was a negative before on the way over, so it's going to be positive when it's over there. So x equals -1. Both those are right. Okay. Now I'd suggest doing that when you only have a variable, when a constant over here. This next one, I couldn't really do it. It's going to get really messy. Okay. But if you have just a constant on the other side, feel free to do that. But you notice each answer is the same. So next one. So I have a bracket on this side, a bracket on this side. So first thing I'm going to do is I'm going to rainbow each side. So that's going to give me 8x plus 12 equals 13 minus negative times positive minus 15 plus 10x. Now, I don't like having 3 terms on this side. So I'm going to simplify this side first. So I'm going to write this one out again. 13 minus 12 is -2 plus 10. So I just combine those to get that. Now I need to bring my letters to one side and my constants to the other side. So my biggest constants, or my biggest variables over here is 10. So I'm going to bring this over this way. At the same time, I'm going to bring this over this way. So what's over here is 12. -2 becomes a plus 2. So over here is 10x. 8x is here. It's a plus 8. So it comes over, it becomes a -8. Which is going to leave me with 14 equals 2x. Then we're at this point here where I have a constant with my my coefficient. So I'm going to do, my last step is to divide by my coefficient. So x equals 7. So there is your examples for all those. Okay, so now it's time to practice. So have fun with that.